I'm Tuhin Rao from Pune, India, and today I'm going to give you a presentation on visualizing sound. This is part of assignment 1, Introduction to Modern Musician from Coursera.org. Sound cannot be seen. They're individual longitudinal pressure waves, whose components are amplitude and frequency. So, to get an accurate measurement of such quantities, they need to be visually represented, especially if it has to be processed in a DAW. The first type of representation will be an oscilloscope, in which the x-axis shows the time window and the y-axis the amplitude, which this thing displays the waveform. You can see on the right the waveform. Here we will see the variation of amplitude as it diminishes and as there is an amplitude gain. Notice the frequency remains constant. And now we shall see a variation in frequency with the amplitude constant. There are different types of waves that can be seen in an oscilloscope, and they produce different types of sound. First one is a square wave. Triangular wave. Notice the difference in sound. Sawtooth wave. So the oscilloscope is used to see the absolute waveform for signal testing and for checking for technical details in a line, and also to see how audio is processed from waveforms. The limitation is that you can't see the frequency directly, and you can't see the evolution of time. So the next type of analyzer is the spectrum analyzer, which shows the frequency versus the amplitude. So on the right side you see the spectrum analyzer. It basically shows the entire timbre over a given window of time. So here's the amplitude variation, frequency variation, square wave coming up. You can see all the harmonics and partials, triangular wave, and the sawtooth wave. The spectrogram is used to visually represent sound in an equalizer and gauges performance. Its limitation is that it does not show the waveform, nor does it show the evolution of timbre through time. The third type of analyzer is a sonogram, in which you have the time, frequency, and the color as the amplitude. So it basically shows a time evolution of a spectrum analyzer. So now you see the amplitude variation decreasing in intensity, then increasing. You can see the color change, frequency variation, and now the square wave, the huge spectrum, the triangular wave, and the sawtooth wave. So the piccolo, flute, clarinet, and the phalanchon. The strings are violin, viola, cello, and double bass. 5 piano strings, for some processed sounds. Sonogram is used basically for seeing how the timbre evolves through time, especially used for instruments and voices which have variation in timbre. The only limitation is that it does not show the waveform. So to summarize, the oscilloscope shows time versus amplitude, spectrum analyzer shows frequency, amplitude, and sonogram shows time, frequency, and amplitude. And you can see the various features and limitations of each type. Thank you for watching my presentation. I hope all of you have enjoyed it, and I would love to see your reviews on this presentation of mine and some constructive criticism as well. Bye.